So I was at this AI conference in Macau, right? And then one Chinese student who was sitting there looks at me, that he gets up, bows to me and said, I learned ML from your videos, and gave me his seat. AI is not going to take your job away, but somebody who knows how to use AI to do your job is going to take your job away. Then director Professor Anand, he never believed in this artificial boundaries of departments and subjects and things like that. People were just teaching subjects, and students used to put together their curriculum based on what they are interested in learning.
Hi, my name is Amrit. We've heard that IIT Madras is the best place to build. So we've come down to the Sudhan Shankar Innovation Hub. We want to meet some people. These are builders. We want to talk to them about their work and also ask them what makes IIT Madras the best place to build. Hello and welcome to the Best Place to Build podcast. Today we are sitting with Professor Ravindran, who is the head of the Wadhwani School of Data Science and AI at IIT Madras. Professor, welcome to the podcast. We know each other for a while now. We traveled together to Bangalore to meet JEE aspirants earlier this year. That was a great experience. What I remembered from it though is that both of us drink black coffee now because we can't digest milk very well.
Sure.
And also I remember that I had given you the Best Place to Build sticker that day and you immediately put it on your laptop. Yeah. Yes. That was amazing.
Because I strongly believe that this is the best place to go.
Yes, sir. And I also, it's amazing how popular you are among the student community. Your classes are taken by hundreds, 200s, 300s of students. And I want to start with the question that, was it always like this? In the sense that, was AI this popular?
So I have been with IIT Madras since 2004, right? And in 2004, I started teaching the course on reinforcement learning, right? At that time, people had not heard of reinforcement learning. So whenever I say reinforcement learning, and my office used to be in the building science block, so people thought I work in concrete, right? So
Reinforced concrete.
So the first time I taught this class, there were about 6 students in the class, right? And ironically, in the early days, there used to be more non-computer science students were taking my reinforcement learning class than there were computer scientists, because reinforcement learning is such a wonderful subject. It has motivations from control theory, it has motivations from neuroscience and cognitive psychology and so on and so forth. So I used to have people doing PhD in neuroscience in my class and so on and so forth. But the class used to be so small. 5, 6 students. I think up until about 2012, the largest reinforcement learning class I had was about 16. Now the smallest class is about 130. Right, so year on year, now we get about 180 students who take it, and then the first assignments and the first quiz rolls around, and then I'm left with about 110, 120 students. About 50 drop the class after that, but still a very popular class. It's not always been like this, but I'm happy that we are.
Yeah, and you, not just the courses you take for machine learning and reinforcement learning, which are very popular, you're also involved in the data science online course, which I think, how many people take it?
Oh, yeah. So that was about that number keeps changing almost weekly. I think we are 35,000 plus now.
35,000 plus enrolled in the
Online BS in data science and AI, right? So that's an amazing team that runs this. So I basically teach reinforcement learning in that program, but then there's a lot more that is done as a full degree program, and a lot of people put in effort to make it as rigorous. In fact, in some cases, I would say even more rigorous than classroom taught courses. So I think it's been an amazing experience both for the teachers and the students.
In fact, I read today morning that a lot of students who, for whatever reasons, haven't managed to get into IIT or who are in some other college, end up taking the BS in data science and sort of augmenting their skill set. It's amazing.
In fact, it's not just people who didn't get into IIT. There are people who are enrolled in IITs who are also doing this as an additional degree, because their primary degree could be in something very different. They're also doing this as an additional degree. And in fact, some of the courses are so good, right? So we are allowing even our regular BTech students to take them for credit. So that's where we are now.
And I know that so I graduated in 2008 and I entered IIT in 2003. So a lot of my friends sort of missed the machine learning, AI, reinforcement learning wave. So a lot of them have uh, subsequently learned it. I didn't, but subsequently they have sort of learned it. And a lot of them come back and tell me that we actually started with Professor Ravindran's NPTEL lectures. So your NPTEL lectures are also very popular. So
Yes, they are. In fact, they still remain a useful resource. So I think we hit a sweet spot, right? So most of the online content are pretty light on the formalism, and then they don't introduce the math. They just directly jump into what I call a kind of a laundry list way of teaching machine learning. They just go through the algorithms, right? Instead of talking about the fundamental principles and so on and so forth. And I think we hit the sweet spot because it was not really designed as an MOOC, right? If you look at my machine learning and my reinforcement learning NPTEL lectures, they were actually taped in my classrooms. So this is designed as classroom lectures, and the interaction that's going on with the students adds a lot of value to these videos, and that is, kind of gives a literally an immersive feeling to the people watching the videos, because they feel like they're part of the class, they're watching it along with the students. I think that was actually very helpful. I think.
yeah, but on this point, so we are tracing back from 2003, 2004, 20 years back, you have 6 students. 2014, you have, I don't know, 200 students. Yeah. And now it's like 400 in classroom, 35,000 in online degree, and another, I don't know, 100,000 in NPTEL. It's
So
amazing.
the NPTEL machine learning course is fairly popular. I think about 8,000 people write the exams, and so a lot more take it, right? I mean, many people start doing it, but they don't come to write the exams. For 8,000 people write the exam, every time it is offered. And it has been offered, oof, 35 plus times now. So a lot of people have looked at
It's safe to say that a lot of people, a lot of students in India have been in your lecture in some way. It's amazing.
Can I tell you another anecdote?
Yeah.
So I was at this AI conference in Macau, right? Then I walk into this room, there's some talk is going on, the room is fully packed, and I'm just standing room one day, I'm standing at the back, right? And then one Chinese student who was sitting there looks at me, he gets up, bows to me and said, I learned ML from your videos, and gave me his seat. So not just India.
That's good.
NPTEL has been an amazing program, right? The reach
Yeah.
is unimaginable. There are so many people in low middle income countries, right, who even learn basic data structures, programming, and fundamentals of thermodynamics and things like that from NPTEL videos. In fact, one of the reasons they're able to connect with it is our accent of speaking English is more understandable for those guys than
The Western.
Western accents or the Coursera's and things like. So a lot of people actually learn from NPTEL videos. NPTEL has been an amazing game changer, not just in India, but a lot of countries.
It's very interesting. Can we come back to this? So the course we were talking about is reinforcement learning and machine learning. I understand that your area of interest, your area of research started from reinforcement learning. So can you tell us a little bit about what that is and what you were researching? I know from the friends and my research team that you are a very well-respected um, researcher in that field. So maybe if you can give us an overview.
Sure. So normally when people talk about machine learning, right? So how it operates is that you have a set of quote unquote labeled examples. So what do I mean by that? So that is a specific input. It could be an image, it could be, a set of numbers that you give, and you expect the machine to produce a certain output, right? So it could be, okay, if this is an image, I want you to say it is an airplane. Or if this is an image, I want you to say it is a deer, right? So that's basically what you are wanting this to learn. And mathematically, if you look at it, what that machine is doing is learning a function that takes the input and maps it to a specific output. But there are a lot of problems which do not naturally fall in this paradigm, right? The usual example I give is a lot of learning to cycle. Suppose you're learning to cycle. Nobody can sit down and say, okay, if your cycle is going at this speed and it is tilting at this angle, then you should push down with your right leg with so much, pounds of pressure. When this kinds of, labeling is just doesn't make sense, right? When you're trying to learn a cycle. The typical feedback you'll get is if you're a kid learning and that there's a parent watching you or or an elder watching you, and say, oh, please be careful, don't fall. Right? So things like that, right? So that's all the kind of instruction you're going to get, not saying what's the exact output you should be producing, right? So these kinds of problems where you're getting, very minimal feedback. Somebody's telling you you're doing something wrong. When they say, hey, careful, careful, that means they're telling you you're doing something wrong, but they don't tell you what is right, right? So such, kinds of problems where the feedback is more, more sparse, right? Where you're not, somebody's not telling you what's the right thing to do, but is evaluating your output, right?
As you're
That
saying
is
this,
reinforcement learning.
as you're saying this, I'm reminded of my swimming coaching experience in IIT Madras, where we were taken on top of a diving board, the Olympic size swimming pool, and the coach just pushed. I died. I mean, I didn't die, but I had to be rescued. Okay. Um, so are you saying that?
That's that's very extreme. But suppose you're swimming, right? I mean, think of it, right? So, in fact, a lot of things that we do, not just cycling, right? Swimming, walking, even talking as baby, right? So, all of this was learned through this kind of a trial and error model, right? You try something and somebody tells you whether it's working or not, or you yourself realize, oh, if you're a baby, you get up, you try to walk, you fall down, right? So, you realize that you're not doing it right, and then you keep trying it again. If you're pushed into the water, right? And then you're trying to swim. Somebody says, no, 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 don't do that. Keep your head down, right? But that doesn't really tell you that, what you should be doing to stay afloat, right? So very kind of minimal feedback that is coming from understood. That is what reinforcement. I mean, the mathematical formalism that allows you to learn is what reinforcement learning is. Understood.
I feel like today there's a large awareness of AI, and
Mhm.
maybe I can understand what you're saying. Like, but 20 years back or 30 years back, when you were a student, how did you get into this field? What interested you?
30 years ago, AI was hot, right? And then it cooled off and then it became hot again. But I didn't get into AI just because it was hot. Because I went to a small engineering college down south. And so the people are not teaching AI or anything like that. But I got fascinated, more from trying to understand how humans think, right? It's all got kindled by the kind of frenzy that was around the AI beating human beings in chess back then, right? So there was all this chess playing program.
These are the
Coming up.
Kasparov matches.
Kasparov matches came a little later, but I mean the one where Deep Blue beat Kasparov came a little later, right? That's late, like the mid 90s. This was early 90s is what I'm talking about. Right? So there are still computers that are playing them, but then the humans, it was competitive with humans. So there's a lot of because of Vishwanathan Anand, right? So chess was a lot more popular in Tamil Nadu than elsewhere. So we used to follow what was happening, and kind of all these AI models were starting to beat humans in chess. And so I started thinking about, okay, what are these models doing, right? How the bigger fascination was these AI models were supposed to mimic how humans think, right? So I wanted to understand how these models work. So I picked up books on my own, right? And I started reading about neural networks and AI in general. And then I got a little disappointed because AI by then, neural networks particularly, by then had become a mathematical tool. And they had moved far away from their biological origins of trying to explain how the brain functions and so on and so forth. And so slowly I started reading up and started exploring stuff. And then I came upon reinforcement learning. This is back in 93, where at that time people were doing experiments with monkeys, right? They're sticking electrodes in monkey brains. But and then looking at how the neurotransmitters and signals were varying in the brain as the monkey is learning stuff, right? And then they came up with reinforcement learning. They said, oh yeah, this field called reinforcement learning seems to explain what is happening in the monkey's head. And that kind of became a motivation for people to look deeper into RL, right? And that kind of fascinated me. And then I started looking at reinforcement learning. Again, turned out I had to learn a lot of optimization to follow reinforcement learning, but still the motivations were more closer to the biological origin.
You are talking about a time when, uh, as a student, you were maybe anticipating that these algorithms or these computers will eventually beat humans at chess. And then they did.
That happened, yeah, in a few years after that, yeah. Yeah.
Must have been exciting.
I was really excited that called me, yeah.
Must have been really exciting. Yeah. And now they've obviously humans are beating you. I mean,
Yeah. So I have this nice headline that I use in my talks, right? So in 2022, there was a headline say, "Man beats computer in Go." What's up?
given that computers are smarter than us at chess and go.
At Go, yeah. The man beats computer at Go is basically love become used to it. Sure. I mean, I don't want to use the word smart. They're better than us.
Better,
Play
better than. I was so in your research, I think at one point you talk about is the word bandits. Can you explain that to it? It's very fascinating. I mean, I don't even know what it means, but it's very fascinating.
In fact, the term bandits, right? It's actually it's usually multi-armed bandits. That's what the term is. The whole problem setting itself, right, predates quote unquote reinforcement learning. Right? It was studied by statisticians for more than a century now. So the idea is something very simple, right? So you have a situation, right, where you have like n choices, right? You can do X, Y, Z. Let's just stick it with two choices. Let's stick to two choices, right? So you can either go to a movie, right, or go to a restaurant. Okay, only these two choices, and now you choose which one you want to like. So sometimes you go to a movie, it's great. The movie, it's a great movie, and you get a fantastic reward. Other times you go to a movie and it really sucks, right? So it's, you don't know whether what kind of enjoyment you're going to get by going to the movie unless you actually go to the movie and test it out. And likewise, food, right? You might go to a restaurant, you order some food, and you might fall sick, or you might order some food and it's like amazingly good, right? So you don't know what is going to be the outcome of this. You have some notion of what could be the outcomes, but you have to actually try these things out before you know what's going to be the exact outcome. Right? So there are many problems that are modeled like this multi-choice problems, where you have to actually test it to know what the exact outcome going to be. Right? So these kinds of problems are essentially modeled as these multi-arm bandits. And the reason for the term bandits is very interesting. Now you see what it is. It's nothing to do with bandits, right? So it's basically a multi-choice problem with the stochastic outcomes, and you're trying to optimize for it. But then if you think about the term, right? So it goes back to slot machines. So, slot machines, right? You put a coin, you pull a lever, and the coin and the machine takes your coin, right? I mean, that's how it normally operates. Occasionally, they give you back a few coins to keep you engaged and keep you going, right? So you can think of it that way, right? So in the slot machine, you basically have only one choice that you can make.
Yeah.
Pull the lever, right? Once you pull the lever, with some probability, you get some positive outcomes. Otherwise, you get a negative outcome, right? So people kind of said, okay, this looks like a bandit problem. Okay, I have to tell you what's bandits. Looks like a slot machine problem, but slot machines had a very colorful name. They were called one-arm bandits.
Oh,
They have one arm. You pull the arm and it steals your money.
that's why.
That's called a one-arm bandit. They said, "Oh, this looks like a slot machine, except that you have multiple slot machines, and you can pull. You can choose which arm to pull. So instead of a one-arm bandit, you have a multi-arm bandit. That's where it comes from.
That's very interesting, guys. So
In fact, I forget. There's an airport in the U.S. which actually has a slot machine museum. Maybe Detroit. I don't remember which one. They actually have a slot machine that is dressed up like a bandit, and it has this one hand that you go and pull. It's really cool. I wanted to take a picture of that. I missed it.
we'll pull up a picture for this podcast and show it at this point to the users.
Sure.
And the other thing that I found very interesting, the terms that I picked up, and I know you have a problem with the word terms, with the use of terms in AI. The term I picked up and it resonated with me, and I thought about it for a while. Is there a trade-off between exploration and exploitation?
That is something that is at the heart of reinforcement learning. Okay. So let's go back to the simple example that we had with the bandits, right? So there is a movie, and that is food, right? So it turns out that let's say I'm a latent foodie. I mean, look at me, you know that I am. But let's say that I'm a latent foodie. I haven't realized that yet, and I would actually love to eat food more than go to movie, right? But then let's say I try going to a movie, and let's say I end up in a great masterpiece by chance, right? So now I'm going to say, okay, that's great. That's movies are great. But let me also try food once, because I don't know if maybe I'll get a better experience with food. I eat food, and then maybe I eat something that I'm allergic to, and I vomit, and so I say, hey, okay, going out to restaurant is a bad bet. Let's just stay home and eat. Let's always go to movies, right? But it turns out, on an average, movies suck in general nowadays, right? So there are very few good movies that are being made. So you keep going to movies, you kind of settle down. Okay, yeah, blah. Okay, movies are fine, but they're way better than vomiting,
Okay.
right? So now I've started exploiting going to the movies. But if I had explored a little bit more, saw a few more movies and eat and go out to restaurants a few more times, I might have decided, hey, restaurants is what I want to do, right? So that's where the exploration versus exploitation trade-off comes in. I very quickly started exploiting based on a couple of outcomes, right? Going to movies because they seem to do well for me. Exploration is when I'm actually trying out multiple things several times before I decide what I should do, right? So because I was telling you, right, unless you try things, you don't know the outcome. In both in reinforcement learning and in bandits, right? Unless you try things, you don't know the outcome. Therefore, you have to explore. You have to try things. If you don't try things at all, you're not going to learn anything about the system. So you have to try things. So exploration is essential. But then, as soon as you find something that is reasonably good, you can start exploiting it, right? If you start exploiting too soon, you might you might end up with something that is not the best solution for you, that is suboptimal. But if you continuously keep exploring, you are leaving out an opportunity for, getting your enjoyment, right? So because even though you don't like going to movies, you keep going to movies just so you want to explore. So that's not a great idea. So at some point you have to decide, I'm going to switch from exploration to exploitation. You shouldn't do it too soon, shouldn't do it too late. That's the dilemma. So when do I switch? And that is at the crux of a lot of reinforcement learning problems, and it makes RL hard. To solving this exploration exploitation dilemma.
It's very interesting that we are talking about this in context of RL, but it's true about human life.
Human life. True, but all kinds of decision making where you have to try things to know what the payoff is really, right?
Yeah.
There are, I mean, life is complicated. There are very few things in life that you can model exactly so that you know what the payoff is going to be beforehand. You only have a rough estimate of things. So so in fact, and it's not even called a trade off. It's called the explore, exploit dilemma.
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 Yeah. And that's a great phrasing. I think students who end up at an institute like IIT or IIT Madras, where there's actually a lot of choice, uh, including whether to take your machine learning class or not. Uh,
The students are complaining there's no longer their choice but in me.
I think it definitely that's running in their heads. It's interesting. So let's move on.
So I'll just explain why I said it's no longer their choice.
Okay.
Because they're getting allotted by lottery now.
Is it?
Yeah, because they just apply, and then if you're in, so the first 100 people who apply, then you get it.
But that's because everybody is applying.
Everybody's applying. So it's not their choice whether they would get to do it or not. It's more like a system's choice. Not that.
I mean, if they don't get the direct classroom, they can go to the data science classroom, the online data science classroom, the NPTEL course. I guess. Okay.
Yeah, they'll miss
Um,
jokes.
They'll miss your live jokes. Right.
I get my recorded jokes still, yeah.
You get their recorded jokes. Professor, I want to say that I've heard you say that AI is the new CS uh, in multiple forums. So I want to understand this a little better.
So if you think about how computer science as a discipline evolved, right? So in the early days, computer science was mostly math, right? So mathematicians used to do computer science, and then slowly became something which got clumped together with electrical engineering. Even now, if you see a lot of departments worldwide, they're called EECS, right? Electrical engineering and computing, computer science, right? So the idea here is that so much about building a computer was about electronics and electrical engineering. So you needed to know how you'll design the chips and how the different components communicate with one another, and so on and so forth. So a lot that you had to know about building the whole system before you can get into learning about computers. But now, slowly in the 80s, what happened was computer science as a discipline matured enough that there was enough to study about computing, right? About writing programs, about structuring programs, and thinking about higher levels, right? Thinking about algorithms, thinking about protocols. that you could move away from the actual details of how the machine itself was put together and start thinking about higher level concepts, right? And then computer science started pulling away from electrical engineering. That the reason it could do that was because computer science had a lot of influences coming in from other disciplines. It was never just a sub-discipline of electrical engineering. So there were a lot of things coming in from logic, things coming in from mathematics, right, and so on and so forth, right? So computer science could mature as a field. So that is sometime in the early to mid 80s is when that started happening, right? And AI is now at the same situation that computer science was back then. So far we have been studying AI as a subfield of computer science, but it's not truly that. I mean, there is a lot of influence from psychology, right? So people have, in fact, some of the earliest AI researchers were psychologists, right? So a lot of influence coming in from psychology, a lot of influence coming in from control engineering, from economics, right? Apart from logic and algorithms and systems and so on. So now you're at a point where we don't necessarily have to know everything about how computing is done to be able to do meaningful and strong AI, right? Meaningful and more fundamental AI research and AI solutioning. Therefore, it's time for AI to pull away from computer science and become a discipline in its own right. I think the field has matured enough that we can start thinking about it. So that's why I'd say AI is the new CS, because it's exactly where the CS was in the mid 80s, right? So now the AI is in the
It's interesting. At
most.
IIT of Madras, of course, um, the Wadhwani School of Data Science and AI is like a new department. I think it's the 18th department at IIT Madras. And so, how did it come about? And also, can I call you the co-founder of the Wadhwani School of Data Science and AI?
Sure.
Okay, that. So please tell us the origin story.
Sure. Uh, so, um, so in IITM, right, back in 2015 itself, so we had kind of started thinking about AI and data science as a strongly interdisciplinary field. This is not just something the computer science or the management school folks do, but we found that a lot of people were actually not just using AI as a tool, but were actually developing new algorithms so that it could work well with their disciplines, right? Whether it is chemical engineering or biosciences, people are actually coming up with new algorithms that would work well for their kind of applications, right? So we felt that we should synergize this, and this was facilitated by our director back then, Professor Bhaskar, who actually said that you should start an interdisciplinary group that looks at data science and AI. So we started working back in 2015, and over time, what has happened is there are multiple degree programs that we offer, which students from different departments. In fact, we have this interdisciplinary dual degree program on data science, which almost every department student gets into it, except CS, right? The computer science students never opt for it, but all the other department students opt for it. I think at one point of time, I had students from 12 different departments doing a dual degree in data science.
This is the IEEE interdisciplinary dual degree program.
Yeah.
There are 10 of them, and you're talking about the one in data
Actually
science.
more, yeah, there are more than 10, but okay. Yeah, the one in data science was the one of the first that was started and still the most popular, right? And still has the largest student strength, right? 75 students take it every year. The idea here is that you do a BTech in some other program, but you do a master's in data science, right? You get a 5-year, do 2 degrees. So that's basically the idea. And a lot of students were taking it, right? So basically, there were many such interdisciplinary degree programs that we were offering, and a lot of interdisciplinary research centers that we were starting, right? So where there will be an AI, data science and AI center, but faculty from many different departments. Computer science was certainly one of the largest, but we had people from chemical engineering, management school, mathematics, civil engineering, every department, right, was contributing to research and activities in these interdisciplinary centers. So at a point we said, look, there's so many activities that are going on, right? And we really don't have a proper mechanism for doing all of this. So let us do a department of data science and AI. I mean, literally, we were doing all the jobs that a department was doing without the department, right? So we said that now it's about time we started a department of data science and AI. We wanted to take a larger view of it, right? Because there were so many interdisciplinary centers already running, right? And we are at all these degree programs. So instead of just launching a department which will administer the degrees, we kind of set up this as a larger school of data science and AI, right, which had the degree programs as well as all of these centers that were operating under one umbrella. So you could say that the School of Data Science and AI kind of houses most of the primarily AI activities in the institute right now. And once we decided that we are going to go ahead with it, we approached Sunil Wadhwani, who is one of our distinguished alumni, and he readily agreed to support the school. So that's why it's the Wadhwani School of Data Science and AI, with supported. Of course, it's supported largely by MHRD. So we have to say that the Ministry of Education is giving it's a standard department like any other. Right? So you're getting the same budget that's from the Ministry of Education, but we're able to do a lot more thanks to the support from Sunil Wadhwani. He actually gave us about 100 crores for supporting the department. Right?
Professor, I'll just say what I heard. Correct me if I'm wrong. So three things coming together. One is that AI as a field grew at large enough. Second is that there were already lots of interdisciplinary things happening. They could coalesce together. And third is that we had this alumni who was very keen to support this initiative. Yep. Sunil Wadhwani. Right. Nice.
So I should say, even if Sunil hadn't given the money, we would have gone ahead and started the department. But that was the kicker.
Okay.
That we did. That was really the last thing that tipped the scale. Yeah.
Nice. Um, I mean, it's interesting that today, of course, a lot of professors are founding companies with their students or with their with each other and so on. And the entrepreneurship scene in IIT Madras is blowing. But I was interested to see that you have been at the start of this AI department, also of other AI initiatives like CRI, the COE in AI, the Robert Bosch Center. Um, how is it? I mean, if you could tell us a little bit about these things, and also what I'm interested to know is how is it different or how is it similar to co-found a department versus to build a company or build a department versus to build a
See, the one thing that is common between both is that the team is important. Right? Whether you are founding a company, I mean, I've heard BCs tell me that I don't really listen to what the pitch is. I look at what the dynamics is between the co-founders before I decide whether the company will succeed or not. Something similar, right? So if you don't have a set of like-minded, motivated people coming together, any of these large initiatives that we are doing, the departments or centers that we have started would fail, right? So that is the thing that is very similar. But then the whole bunch of other things are different. What is our what are we looking to in terms of delivering and things like that? All of those will be very different, right? And we are not essentially shooting at a single product, right? Like a startup would be, right? So it's not you don't have this. You need to have this one single unique product that we are going to take to market, and we have our product is very different. It's more like enabling a culture of research and innovation, right? That's a lot more vaguely defined product, and so we have to worry about what kind of KPIs that we will look at, and those things are different, right? So how you are evaluated and how you raise funding, all of this is fairly different. But then you have to raise funding. That is something common to. I mean, as a prof, right? I just sit back, go teach, and I don't have to worry about raising money because the government gives us money. But if you want to do something different, you want to start a big center, so you'll have to do fundraising, and you have to make sure that you improve your visibility or making you have KPIs and you're achieving that. So in some sense, having this kind of a quasi corporate culture in how we organize our research and how we do our academic activity really helps us stay focused, as opposed to just doing the usual, work as usual routine that normally sets into department. So the similarity is that, yeah, so you have to, build a great team. You have to do some amount of fundraising, and then you have to keep your eyes on your deliverables. Of course, there's one other thing which is very common to startups and academia. And so I have 100% guaranteed attrition from my workforce.
department.
So
Because your researchers will
yes,
eventually
they have to
graduate
yeah,
and leave.
yeah. So one of their performance metrics is how soon they leave. Right. So it's not that I can retain people for a long time unless I turn them into like a
If a PhD student is staying back, that's not good for anyone. Why don't we talk about all the individual initiatives that have coalesced into the
I can do that. So the first initiative that we started with in this whole interdisciplinary journey, right, was the something called the Interdisciplinary Lab for Data Science. Okay, and that started back in 2015 December. with some small number of faculty coming together and deciding to look at what we call network science or network analytics, right? And this is basically looking at not applying machine learning not to individual inputs, but to a set of connected inputs, right? It could be like users in a social media network, right? Or it could be a transportation, like a road network, right? The nodes, the intersections or the data points, and I want to predict congestion, but they're all connected together. Or it could be in biology, network of interacting organisms, right? It could be that. So we had different people. So we had people from civil engineering, we had people from control theory, we had people from biology, everybody studying how do you use AI on networks. So we started a group back then with this, right? And then they're actually doing a lot of engineering applications as well, right? Then Bosch, the company, came to us and said, "Hey, we really love the way you are looking at AI as an engineering discipline. So we will come with you, right? So we will fund you. So let's start this Robert Bosch Center for Data Science and AI." And that's where we did. So we had about 2 years of the interdisciplinary lab of data science. It kind of morphed into the Robert Bosch Center for Data Science and AI. And that was in 2017, August. And since then, that has been in operation and has grown in size, right? We started with something like 13 faculty members, a few of whom actually left the institute after that. They retired or they moved on to other things. So I think when the Robert Bosch Center started, we had about 15 people from different people. And now it has grown to 38 faculty members who come from 14 different departments. We started with 6 departments being represented in the Robert Bosch Center. Now the 14 departments that are being represented. We have run like close to 100 projects from the center. There are nearly 250 papers that have been published from the center, and at least a couple of startups that we have enabled from the center. All of this has happened. So a lot of activity happening. Several hundred students have gone through the center, have graduated, and it's been fairly well established now. And in fact, we have had people from other countries come and when they visit IIT Madras, "Oh, we have heard about this Robert Bosch Center. Can we go and visit that?" Right. So it used to be CFI, only get investors coming to Robert Bosch Center as well. Okay. We should talk about CFI.
We'll talk about CFI,
Okay.
but
Then
not now.
that is the Robert Bosch Center, right? It's kind of still continuing, even though Bosch has decided to shut down their research operations in India and move back to Germany. So they're not funding that initiative anymore, but we are still active, right? And then we also had this other center on systems biology, right? It's called IBSC. So IBSC looks at AI applied to biological systems, right? It could be gene networks, it could be proteins, so all kinds of omic studies. And then we are now looking at things like drug discovery in IBSC, and then drug design and discovery. And we also look at microbiome research, AI applied to microbiome. In fact, some of our teams have even studied the microbiome in the space station, right, and the International Space Station. So they're part of the team that did that. And so that's another active the thing that's roughly started around the same time as RBC Design is still going very strong. So we have people, and that we are using that to also launch our AI COE in healthcare now. That's going to come in. So a lot of people who are originally part of the IBSC initiative are going to be part of this healthcare initiative as well. And then as we kept going, there were multiple other centers that were coming where I was not actively involved. See, once the Robert Bosch Center started, right, it set a template for others to say that, hey, this is how we should build interdisciplinary research centers, right? In fact, a lot of the centers in the campus use the exact same governing structure, exact same process for operation that the Robert Bosch Center uses, right? So almost all the interdisciplinary centers on campus use that, not just on campus. When IIT Bombay and IIT Delhi wanted to set up their interdisciplinary centers on AI, they came to us as our template. Hey, we see what you have done with the Robert Bosch Center. Here, we want to copy this, and in fact, IIT Delhi said, "Oh, we want to copy this. Please tell us all the mistakes you made so that we don't make them."
I have a feeling that now that we have a department in AI,
Yeah,
they will
going to follow soon.
Yeah.
Yeah, they're already talking to me about it. They're trying to get me get some inputs and things like that. So it's been an amazing influence, right? Not just within IITM, I mean across the country, the robot centers had an influence. So after that, in the last year or so, I have been more active in setting up this Center for Responsible AI, right? So the reason is, AI is still a technology that is developing, right? We can do a lot of cool things with AI, but doing a proof of concept and then going into actual field and deploying a product, And there are a lot of difference. So people have been through this journey, understand that. So
Yeah. I remember that Google Gemini once suggested that put glue on pizza to make it more cheesy. Yeah.
no. So somebody said, "Oh, my pizza cheese keeps sliding off my pizza. What can I do?" And then the Gemini said, "Put glue on it so that it fixes it." And the reason it did that is actually very interesting. It was not hallucinating it. It was not making it up. It actually pulled a search result and rephrased it. And somebody had written a prank article on Reddit about how to fix cheese to pizza. And Google just retrieved that the prank article and then thought it was truth
I mean,
and produced.
can it tell whether it's truth or not?
Um, Good point. It can try to detect sarcasm, but sarcasm detection is one of the hardest problems to solve automatically, right? So I know many humans who don't get sarcasm. Forget about AI getting sarcasm, right?
Yeah.
So that's a challenge. Okay, that's an aside. But then that is a huge problem, right? So what I was finding to a little bit to my worry is that a lot of governments in India, a lot of state governments, and even the central government in India, were trying to push AI into public services, right? Looking at things like law enforcement and also other public facing services, and they were trying to use these AI models without even understanding what are the pitfalls, whether the AI is truly ready for solving the right. So I got a little worried. I mean, we'll put ourselves into a major hole if we go that way, right? So I started pitching for the Center for Responsible AI, where the whole idea was to understand how to use AI in a correct fashion, right? The responsible fashion. As we should have called it Center for Responsible Use of AI. Doesn't quite have the same ring, right? So we just went with Center for Responsible AI. So that's something that I'm spending a lot of time with. And we have actually taken the interdisciplinary concept to the next level with Center for Responsible AI, because when we're talking about any technology interacting with humans, right? It's not just enough for the technologists to think about it anymore. You need, sociologists, you need economists, you need lawyers, you need a whole bunch of other disciplines, right? Who needs to think about it? I mean, so usually the complaint from other disciplines is technologists look down their noses upon other non-technical disciplines, but then in the last year and a half, I've come to understand that everybody brings a very, very valuable, viewpoint to this discussion. So we are trying to expand the scope of CRI to get in non-technical people into the conversation as well.
The interdisciplinary nature of modern life um, is actually quite hard for a lot of people to comprehend. And we interact a lot at Ask IITM. We interact a lot with parents of students who are applying to IITs or to other colleges, and they have to make these choices between chemical, meta, CS, AI, CS at IIT Bombay versus CS at IIT Madras, or AI at IIT Madras. So in these making these choices, they sort of struggle with the idea that the choice is not that strong a choice. Would you say that's true? Like, I think because of how interdisciplinary the world has become.
So the undergraduate discipline that you end up doing, right, influences the choices that you get later in life. Influences, doesn't determine, right? There's not something that is predestined. Okay, oh, I didn't get into computer science in IIT Bombay. That's it. I cannot do anything in computers in my life anymore, right? That's not true, right? So people actually diversify quite a bit, right? I know I have a cousin who did chemical engineering, but now works with aerospace engines, right? So it's like where to where, right? So you can actually, the way that the f- the fields are moving now, the kind of resources that is available to you, you can move around, right? But the discipline that you get into does certainly prepare you for certain kinds of jobs. Yeah, right. So that is important. So if you want to get a head start, right, to think about what is it that you want to learn, what is it that you want to do, and go for that, right? I would say that the student interest and the focus on what they want to learn, what they feel excited about, is more important in choosing a branch than thinking about, hey, what will be my career prospects 20 years down the line, because there's just so many imponderables that you can't say that for sure at this point, right? And in fact, the other day I was having a conversation with one of my school friends, and then suddenly he just woke up. Hey, you did your master's in AI, right? and you're still working in AI. You're the only guy in my friend circle I know who is doing that. Okay, wow. You're actually doing what you wanted to.
Yes.
So that's how the field, that's how the life is, right? So people are learning one thing, they're moving on to doing other things. So we have to think about lifelong learning. So yes, so the choice itself, right, is not strongly in one way. It's just like you have to do this, otherwise you're going to be a second class citizen all your life or something like that. No, that's not the case anymore.
But a lot of students do. I mean, you mentioned it earlier in this conversation. A lot of students actually pick up AI and then drop it because they feel like that's not their cup of tea.
Well, I said they pick up AI and drop it because the exams are hard. I didn't say they drop it because it's not their cup of tea. But sure, the people do change, right? So, I mean, in fact, I've known people who have taken computer science, right? I mean, so I've been a computer science like professor longer than I've been in the AI department. Yeah, so longer than I've been in the AI department. I said people take computer science and then switch off in their second year because they decided that computer science is no longer for them, and they would rather do something else. I don't know, come build something with your hand and or get into psychology or something else, right? Not necessarily into computer science. So sometimes this realization comes a little later in life. Some people know it early enough that that's what they want to do. So these things do change, right? But yeah, so but right now AI is very hard, right? AI is
Yes.
super exciting, right? And so I have to. I mean, I will be remiss if I don't say this, right? I think at this point, right? Artificial intelligence is a transformative technology, transformative field in some sense. It's not a single technology. It's not like steam engine, right? So artificial intelligence is something that is going to that brings a suite of new ways of solving problems. It gives you new directions to look at, right? New ways of formulating problems, things that we couldn't even imagine a few decades back that can be solved using automation are now being enabled, right? So it's an exciting time. So it'll be remiss if you don't learn about AI right now, right? Because that will certainly put you in a back foot, right? I mean, not that you need to learn how to do AI, but you should learn how to use AI at this point. I think it's very important.
Yeah. And in our prep call, we were talking about the Nobel in physics and chemistry going joint to AI and traditional researchers in that field. That's a big nod to say that it's become so interdisciplinary and there's so high a contribution of AI to those fields. I feel like I touched a rod.
Well, yeah, I mean, I'm super thrilled that AI is getting the nod for the Rebel, right? So, as somebody was jokingly saying, this is a distinguished alum of IIT Madras, Professor Subbarao Kambambati. He was actually joking about this. Oh man, earlier we only used to tell our students to tell our children to get the Turing Award if you're studying computer science. Now, if you're studying computer science, you'll tell them to get the Nobel also. So much more pressure on the Indian kids. So, so, so that is there. So, but still, but it's an amazing point in time, right? So, and this is not the first time somebody known for his AI contribution is getting a Nobel. But certainly for the first time, somebody is getting a Nobel for contributions in AI itself. So Herb Simon has a Nobel, which was so even though he was one of the kind of founding fathers of AI uh, back in the 60s, right? So 50s and 60s, his contribution, his Nobel was for something else, right? Not for his contributions to AI. But in this instance, both Hopfield and Hinton, the physics Nobel laureates, have gotten their Nobel for their contributions primarily that came from AI. And the kind of the fig leaf the Nobel Committee offered to the physics community is that, don't worry, it's not just AI, because all of the things that these guys built in AI, we are using them in physics as well. And this actually cost us to do huge discoveries in physics.
Yeah.
The way they thought about formulating the problem for solving using neural networks allowed us to, solve other harder problems in physics, right? So that's something that they talked about. And the chemistry Nobel is a little bit more straightforward, right? So the physics Nobel was not actually shared. Both the people who got it were AI folks, right? Like Hopfield is by training a physicist, but
He got it for his work.
work in AI, and Hinton is got it for his work in AI as well. In the chemistry Nobel, so Baker is a is a chemist. The guy has been working on protein folding, protein structure prediction his entire life, right? And so he's not a computer scientist. While the other half of the Nobel went to people from DeepMind who worked on this the AI called AlphaFold, right? That used reinforcement learning to predict the structure of proteins, among other things. In fact, almost everything that DeepMind does has some reinforcement learning in it, right? So it's the reinforcement learning company, really. And so they worked on this AlphaFold, and which actually made a significant contribution to how people looked at protein folding, right? So protein folding is a problem that people have been looking at forever, and it has a lot of different implications, right? It's not just a kind of an academic exercise trying to figure out what the 3D structure of protein is. It allows you to use it, and design drugs, understand various kinds of diseases, understand various kinds of biological processes, and so on and so forth. And so it's a very, very important problem to solve. Yeah.
And AlphaFold has, I mean, transformed the field of protein folding entirely.
Yeah, it does. It does. So the thing is, when AlphaFold 2, right? AlphaFold 1 was fine. AlphaFold 2 was the one that really broke the back, right? When AlphaFold 2 came out, people are actually saying, "Hey, has the protein folding problem been solved?" Right? And there are biologists and biochemists who are actually working on this problem their entire life, who said, "Oh, I'm going to retire now. There's nothing else left for me to do." And there are all kinds of downer articles written in these journals and so on and so forth. But it turns out it's not solved, right? So there are certain kinds of structures which AlphaFold still struggles with, right? Certain kinds of proteins AlphaFold still struggles with. So the focus of the field has changed, yeah, right? But the biggest difference is the following, right? So earlier we used to have databases of protein sequences. You don't know the structure, you just know the sequence of amino acids that form the protein. So people had published database of these protein sequences, which kind of kickstarted research in one direction. Now with AlphaFold, we're able to publish a database of protein structures, right? So which completely changes the set of problems that people can look at and so on and so forth. It changed the field completely.
We were talking about the interdisciplinary nature of AI and in general modern engineering and science, but definitely in AI, where AI people get into AI from all fields, and AI gets into all fields. Yeah, it's interesting. It's almost like never before been so interdisciplinary.
Mathematics.
Yeah. So I want to talk about, you were talking about how student paths are different, and it'll be an amiss to miss the fact that one of the largest companies in the AI space, Perplexity, was co-founder. One of the co-founders is one of your students, and he talks about it. He talks about how he was an electrical engineering student and landed up in the same machine learning, reinforcement learning courses. It's quite exciting. How was he like in class?
Ah, so I mean, I'm speaking the truth. So he was very quiet in class, right? And he almost always dread when he opens his mouth because it's almost always to point out something that was wrong in the lecture. But he was very quiet. He didn't ask too many questions in class and things like that. And of course, he was either the topper or among the top two in every class. And he's one of those guys who come into the class and skew the grading curve so that the rest of the class hates them. You know the kind of guy I'm talking about? Yeah, yeah. So he was one of those. He'll come in and skew the grading curve one way or the other. But it's amazing. So he started doing research projects in his third year. And so we've been working. I got a good 2 years to work with him because of that, right? So and then he was amazingly persistent researcher. And even then, he kind of had a knack of picking problems that people will be interested in hearing the solution to. Right. And the Perplexity was not the first product that he built. Right, he built something else completely different. His first product was something to search through tweets. There's no way Google search actually hit the tweets. Right, there's a lot of information that was being generated in the Twitter sphere, and so he built this thing that will allow you to go through that and then pull out interesting threads of discussions from Twitter. Then slowly that kind of grew into Perplexity AI now, and is doing amazing stuff. Yeah.
That tool is, I mean, at least for us, it's changed the way we look at researching or look at
Yeah.
collecting information.
Yeah. So, I mean, Jensen Hong said that's his favorite search tool. In fact, he said something very interesting. He said, even if I don't have a search query, I like to go and see what Perplexity will tell me about some things. So he uses it at least 3-4 times a day, just out of curiosity as to what Perplexity would tell, even though he knew what the answer he wanted was. That's really changing the way people consume information.
Let's switch topics for a bit. Professor, you were also the faculty advisor for CFI, and we are sitting in CFI. Of course, this is the new CFI.
Yeah.
And this building is about 2 years old, and you were a faculty advisor from 2015 to 18, or 14 to 17, I think.
50 to 80.
15 to 18. Um, how was CFI then? Like, I mean, just for a clarification, when I graduated, CFI was not there.
Yeah.
It started like 2 months after I graduated.
Okay, we just waited for you to leave.
Yeah, thanks. Yeah,
No, in fact, we are sitting exactly in the old CFI.
the location,
Yes.
building is
Right? The building has changed. This is exactly where CFI was, right? And CFI has always been something which, pulls in the students who wanted to do things, explore outside their subject area. So it is always an exciting place, right? And in fact, I think I mentioned this to you earlier. I was the first faculty member to be designated as advisor of CFI. Before that, the co-curriculars affairs advisor faculty used to take care of CFI as well, right? But then I came in and I say, look, CFI has grown so big, right? There's so many interesting things that are happening. There's so many projects that are going on, so many different clubs and thing. And so it needs a dedicated advisor. You cannot have somebody who's taking care of all the co-curricular activities on the campus also take care of CFI. But it needs somebody who's going to do this. And then I said, I can take up CFI, but I don't want to do the co-curricular affairs thing, right? So so we split that, right? So Rajan became the co-curricular affairs advisor, and I became the CFI advisor. So that's the point, right? Literally the cusp when C5 was blowing up. So it was exciting times. And then is when we decided to build this new building. So in fact, I was the C5 advisor when we designed this building, when this building was commissioned, right? And then I stepped down, and the next advisor took over.
I'm curious. We talk of CFI like I mean sometimes I feel like it's taken for granted, right? Like it's there, everybody has access, and we're talking about all these entrepreneurship. And you've just mentioned like we started this center, we started that center, this center, and it's just like I sometimes sit back and wonder. Um, 20-30 years back, maybe it was like this at a smaller scale, but today it feels like there's this massive build culture across IIT Madras, different departments, different student clubs, and everybody's talking about it. And if they're not building something, they're supporting someone else who's building something. What changed? What is in the water?
I think it's something in the DNA of IIT Madras, right? Remember, we started with the collaboration of the Germans, right? And Germans love to build, right? Germans are this guys are so focused on engineering and building things, right? I think somewhere got stuck in our DNA that we also, are building this entire ecosystem and this culture that encourages people to actually become true engineers and true builders, as opposed to just studying something, and from the books and then going away, right? And as you rightly said, most of these things wouldn't have been possible if the support has not been coming from top down, right? So for some of the initial activities that we did, including starting C5, we needed the support of the then director, Professor Anand. He backed it big time, right? So he said, okay, yes, go ahead. Let's do this, right? In fact, Anand was envisaging a ecosystem where if you just go into, a cafeteria, you should find that like 10 different tables discussing 10 different exciting projects, and you should, get motivated by that, go join one group and be able to do stuff, right? He never believed in this artificial boundaries of departments and subjects and things like that. He had this vision about, you know, an IIT where there were no departments and people were just, teaching subjects, and the students used to put together their curriculum based on what they are interested in learning, and research would happen in a very, very fluid, interdisciplinary manner without worrying about, departmental boundaries, administrative boundaries, and things like that. So we have been lucky to have a series of these kind of visionary leaders, and Bhaskar was amazing, right? So when Professor Bhaskar was the director, he again pushed so many different directions, right? And then he prepared the institute for what happened when Kama came out, right? When Professor Kamakoti took over as director, he created two new and completely interdisciplinary departments, right? So medical sciences and technology department again pulls in a lot of people together, and the goal is not just to do teach people, right? The goal is to actually train guys so that they can go make a difference in the field, like who will design new equipment, new ways of doing health tech, right? So that's the whole idea behind that, right? Likewise, the data science and AI department was again enabled so that the focus from the department, right? In fact, if you look at our curriculum also, is a lot of hands-on components have been inserted into the curriculum as opposed to what would be a traditional, just run a few code programs and things like that. But we're actually having a lot more industry engagement in the curriculum itself. So all of these things have been possible because there's been this culture of innovation and building in IIT Madras.
And maybe we can trace him back to the Javan collaboration.
Maybe that's speculation, but it certainly has been true for a long time.
I feel like you're being humble because obviously professors like you and directors like Professor Anand and Professor Bhaskar and Professor Kama have had a lot to contribute.
Yes, that's what I'm saying. Right, the drive comes from the top, right? So so I'll give a lot of credit to the hardware.
Nice.
And of course, I would be completely remiss if I don't mention the research part.
Yeah.
So which was started during Professor Anand's time, right? So he really wanted what happens in IIT Madras to have a real life impact, right? So the way to do that is to connect closely with the industry. And the research park has enabled that big time, right? So a lot of the reason we have more startups coming out of IIT Madras than any other IIT is because of the access to the innovation ecosystem in the research park. Yeah, right. And of course, Professor Jujubala has been running that for forever.
He just retired.
Yeah. But then it's the vision of
Well, I
Anand.
think he
started there.
he was leading the effort for almost 15 years. 2007 onwards.
It's sort of from the founding of the research park onwards. So the vision was Professor Anand's, but then Professor Jinjurwala took over and he was running the whole place, right? And then it continued with under Professor Bhaskar, and then it expanded from one big building to these 5 buildings now that are there. It's become a very very active ecosystem. So that's also had a significant influence in the kind of projects that students take up, right? And the kind of work that they do, right? And also the exposure for faculty to industry.
The scale of the initiatives that are coming up are also becoming larger and larger, and
Funding is available.
more funding.
No, that's one of the reasons.
That's
That's
belief, right?
That's belief.
It's like I love the idea that IIT Madras now has a has founded the Zanzibar campus.
Yes.
Which is like, it's saying that we're done here. I mean, we're doing so well here that we're just going to it's one level higher, like form a department, form a research park, but now we're forming the whole institution, right?
Yeah.
Amazing. So can we go back to a few things that you have mentioned to me earlier about how you were as a student and your journey to IIT. And I remember you mentioned that you were at ISC for a while and you were running a forum in the early 90s.
Page, yeah.
What is it?
Okay, so I got fascinated by the web, right? So very early on, right? Even though we didn't have a lot of internet access in India. So in fact, the first time I sent email was in ISC in the when I was in my master's already, right? So before that, we didn't even know something like email existed. And back then, if you wanted to get a copy of a paper, we write to the authors, like write, paste, mail, and then the authors will mail us a copy of the paper. Right? So it will take us about a month to get it, right?
Okay.
And so that's how it used to be, right? And then this whole web came in, right? It was a new concept back then, right? And not too many people in India actually had access to the internet. Even if you had access to email and things like that, the web going out and looking at the World Wide Web was not a thing. But I got fascinated by this, right? So it started off with me experimenting with this stuff and maintaining what I called a food page back then. This is like what in today's terminology would have been called a blog. But the word blog hadn't been invented back then. So I used to write about restaurants, review them, and write about recipes and things like that. And then I used to give an email address on my page. If people wanted to submit recipes, they could do that. And I actually got recipes from people I never knew on how to cook food and things. And I thought, okay, this is a great way to connect with people. So what we did then, a group of us who were very, very interested in film music, right? All Ilayaraja fans, right?
Such a different time, right? I have heard from someone that early 90s stories that they saw a recipe for pani puri
Uh-huh.
and they made a puri, like a normal puri.
Yeah.
And they stopped it, like how pani puri would be. But it's totally different puri, right?
Yeah.
And you didn't know that because you grew up in the South and it's an odd dish. It's very interesting.
Yeah, so it's different times. So basically, we started this TFM page, Tamil Film Music page. And back then, we didn't have enough bandwidth to host it in India. So we used to do all the things. We made the HTML files, and then we sent it off to a friend who was in Oxford, and he used to host it in his machine in Oxford, even though it was a TFM page. But it
But
used
you were emailing and not posting it.
we were emailing it. Email is fine, right? So email was happening then, right? It's like that's a custom. So we used to send him these things in email, and then he used to post it there in his lab web page. Until the point when the lab basically said, "Hey, you're increasing the traffic to our web servers many-fold, right? So everybody is coming to see your music page, not the academic content on the web pages." So they asked us to take it down, and at that point we started hosting it in a service in Singapore. But it was running strong till about 2 years back. So
Oh, really?
yeah.
Oh, okay.
So we used to get something like, I think at the peak, we used to get something like 15,000, 20,000 visitors a day.
Oh, wow.
So the page it became very popular. In fact, we used to partner with radio programs in Malaysia, and so they'll say, "Oh, go to this page and give us your songs, and we will play them." And here, and we used to have a lot of amazing articles that were written by collaborations on this, right? So one of the things that I did as part of TFM page was create. I mean, I wrote all the entire backend for creating a discussion forum. At that point, there were no like bulletin board services or all these chat services that you could just post, right? I actually wrote the entire backend and the front end. I mean, so all of that, and we started something called a discussion forum, right? And then, in fact, it's a funny story. So I started the discussion forum, and then I came back to India to get married. So I had no access to this. This was after I had gone to UMass, right? So this was in like 96, 97, middle of 97. We started this discussion forum. And then I came back, I got married, and I go back, and I find that thing had just caught fire. Right? There were like hundreds of users on that without any, I mean, without any publicity or anything. The people just discovered it, and then they just come there, and there's like hundreds of users, like several topics that were being discussed. In fact, there are thousands of users, right? And a lot of topics that were being discussed. So then I had to go in there and do a lot of hacking at the back end to make sure the system can scale to this large user base, right? And that was so interesting. So we said, hey, look, so many people are interested in a forum to discuss Tamil music. Let's start a forum, like just like a hub, right? So the word hub comes from Arthur C. Clarke. So he used the word hub to describe certain kinds of space colonies that were getting formed and things like that. In his, so the Arthur C. Clarke has his Rama series of books. Rama 1, Garden of Rama, Rama 2, and things like this. It's like a splinter fraction of humanity gets launched into space, and then they build this whole culture in space and things like that. So he, the main thing there is called the hub. So I said, okay, the hub is where everybody is going to come and start discussing stuff. And so we built something called the forum hub, and it became more popular beyond my imagination. There was like so many different topics. We allowed people to self form. It was really one of the earliest social networks out there, right? So people were coming in, they're forming their own groups there, right? And then they used to discuss various topics, and there are multiple, for example, cooking sites, right, that went professional later. They had their initial start there. So this guy started posting. This guy called Hemant Trivedi. He started posting recipes on this forum hub, and then people just loved what he was doing. And then he went and launched his own web page later. It became very popular. I think it's still running. So I like that. We wrote. We had some of the earliest collaborative writing, fiction writing that was happening there. So people just got together, say, "Oh, let us try and write a book together. Let's 10 of us write books together." And then they was doing this. And there was another person who was actually, we didn't figure out until much later that she was actually an IAS officer. But she started writing fiction on our forums, right? Became so popular, then she got encouraged by the responses she was getting on the forum and went out and started publishing books on her own. And of course, there are people who got married once they got introduced on this forum and things like that. So it became
So
super successful. We're very happy.
I see what you mean by saying that it was like an early social network kind of thing. Yeah, I mean, how far we have
Look at
come, right?
yeah. After I got more interested in RL, and so I stopped pushing that. I mean, if I had got, there are people who actually offered to buy the site. I want to. We refuse to take it up.
So far we have come from then, where email was new and forums were new and RL was.
Yeah, man, I'm old. Yeah. I want to ask you.
I want to ask you about where are we going in the next 5-10 years? Because I think it's a
So we have taken this human connection, right, for granted, right? Also, at the same time, we are evolving a new kind of kinship, right? So I used to think my son is not being very social because he used to sit in his room all the time. And then I find that he has way more friends now than I did. And I've been friends, not Facebook friends. I mean, the guys who know what he's doing, what he's thinking, guys he's sharing stuff with. And all of this interaction is happening online, right? So he had a roommate during his college days, right? And they met online, and then they managed to live together for the entire college time in the same apartment, sharing one bedroom, right? And they had no problems at all. And he didn't know him from Adam before he started taking classes. And they met complete. His first year was COVID, right? So nobody met each other. So all the students met only online, but they figured out how to work. So the kind of kinship and other things that are building, right? So the way people build relationships, I think the boundary between online and offline relationships is kind of blurring. I mean, I have friends who I have never met, who I've met, who I only online, but that thing is, but no, so one of my best friends now is somebody I interacted for 5 years only online. Right. I knew him from '97. I met him for the first time in my life in 2003. Right. So and now he's still friends, and we keep meeting each other. I get what you're saying. That is a one-off thing, right? But now what is happening is that it's kind of becoming the norm, right? So the way the society is going to evolve, is going to change significantly. Boundaries are going to become less critical, right? And of course, unfortunately, it has all this other side effects of people consuming everything from the internet, and yeah, and all the fake narratives and other things that are being peddled. And the other major concern for me is the hyper personalization that is happening.
Yeah, I heard this term called ecoverse,
Okay.
which sort of gives the idea that we live because the algorithms around us work like that. We seem to be living in this sort of bubble of our own making.
Yeah. Yeah. That also could happen. But the bottom line, right? So societal structures as we know it are changing rapidly, changing around us. And some of us notice it, some of us don't. And so most of us are just going along with the flow, which is usually the way it is, right? Yeah. And
And what about what do you think?
I can on bad days I can see the dystopian version of this. On good days, I'm much more hopeful for us becoming more of a global community than not.
What about how the future of work looks like with AI coming in?
So AI is going to affect every aspect of life. So it's going to change how we are going to do the jobs, right? I mean, there was some technology in the past that we are now saying that we can't do without, right? So like that, right? So I like to give this analogy of how we use office tools, all right? So everybody needs to know something about either a document processing tool or a spreadsheet or the slide maker, whatever be your choice, right? You could use Google or you could use Microsoft or whatever, but you need to
Yeah.
know all of
You
these
you
tools.
have to excel at it.
You have to excel at it, right? So, in fact, our most MBA programs start off by teaching you how to use Excel effectively.
Yeah.
Anybody can go and start using a spreadsheet, fill in numbers, and use the rows and columns, right? But if you really want the true power of Excel, you need to go train on Excel. So AI is going to become like that, right? So for everybody to do their job, they need to know what is the AI tool that they have to use in their job, right? It's not like it's going AI is going to take away your job or everything, unless it's a small number of jobs that will get lost, right? I mean, so who runs an STD booth anymore, right? So we STD booths.
Oh, my favorite example of jobs that have been lost in the march of technology. In the 1700s and 1800s, there was a job for someone to go and light all the lampposts which were
Yep.
running on oil.
Yep.
So obviously that's not his job.
That's gone. But I mean, we don't have to go to 1700s, 1800s. I'm talking about telephone booths.
Yeah, telephone booths are gone.
Yeah,
Internet cafes are gone.
When sure, yeah, I know him. Yeah, for me, I mean, telephone booths were a fact of life. So when I was in IISc, right, so we used to go late in the night because that is when the charge rates were lower for calling STD, right? So we'll go there, wait in a queue, right? Wait for like half an hour. There'll be huge queue of people because those are the only few places where you can go and make a call. So these STD booth operators were actually an integral part of our life then.
Right.
Now they're gone. We can't find an STD booth operator, right? So technology has completely, taken away those people, right? Telegrams, right? Telegrams used to be the way of communicating information, right? Not that long ago in the late 1800s, right? So telegrams were the way of communicating information. Right now, telegrams don't exist anymore. Telegraph offices are all gone. So the much of technology is going to make certain jobs go away, right? But it's not as if the society suddenly became jobless because no telephone booths went away or the telegraphs went away, right? So we moved on to other kinds of jobs. Like people are started doing other work, right? So that's how it's going to happen, right? So jobs are not going to get replaced entirely overnight. They're going to slowly move away. But the bigger impact is going to be that every job that's not gone away is going to be done in a different way. You have to use AI to be effective at your job. I don't care what you are doing, right? You can be a cameraman, you could be a journalist, you could be a lawyer, you could be a doctor, you could be an accountant, right? You could do, whatever it is, right? You could be a teacher. But not just I have to teach AI, now soon it's going to be imperative for me to use AI to teach, right? So all of this is going to happen, right? And so I like to quote, you should find out who said this. Okay. I like to quote this statement, right? So AI is not going to take your job away. But somebody who knows how to use AI to do your job is going to take your job away. So unless you know how to do that with AI, so that's going to be the biggest impact. So we're going to get a new set of tools.
In marketing, which is my domain, I've also felt that in many ways, some of the AI tools are forcing humans to rethink what is human about them and how we think of intelligence in the first place. Like I'll give you a real example. Like sometimes we have to write on behalf of someone else or on our own, and I have to write it in such a way that the reader feels like it's being written by a human and not by ChatGPT. And sometimes that's challenging. Like I keep thinking about it. Like how do I write so that the reader thinks that there is a human part of it? So I'm consciously thinking, what is human about writing? Um, and what am I doing better than the machine now, or what am I doing differently from the machine? It's an interesting idea, and I wonder if and of course, you mentioned previously in the call that previously in the podcast that scientists who are working in proteins have stopped looking at protein folding and are looking at maybe harder structures or something else. It's interesting.
Yeah. So it's yeah. I was telling you that artificial intelligence has its roots in psychology, right? So a lot of psychologists were actually thinking about it. The whole idea came from, okay, what does it mean to think, right? And from there is that basically the roots of the problem, right? So when you start pushing the boundary more and more, then it is natural to ask this question, right? So some people say that there is a spark of creativity in us, right? That cannot never be captured by these models. So even though you have these models, right, you still need a human to shape it, to guide it, to do the right thing, because on its own, it's just going to get into a rut, right? So just because if it's just going to maximize the probability of generating a sentence, it's just going to keep generating the same thing again and again, or a small set of outcomes, right? So you really need to nudge it into parts of the output space it hasn't explored, and then get it to do something novel, right? So that is there. But then again, people are trying to kind of get these models to do that as well, right? So all this is they are pushing the boundary, right? So that's the whole intent of this field, trying to figure out how humans think, right? So how humans behave, and try to emulate it so closely that you cannot tell apart what is human and what is AI. So that's the full point about it. But then there's also other interesting ways in which this is affecting humans. I was telling you about Go, right? So yeah. So after AlphaGo, which is the agent that beat the humans very conclusively, came out, right? It turns out in the next 2 years or 3 years after that, humans have changed significantly how they play Go. They have started adopting some of the moves that AlphaGo came up with in the games that it played, and have generalized from there, right? So they have actually coming up with newer ways of playing Go, which kind of got seeded by how AlphaGo was playing Go. Now, even today, AlphaGo still beats humans. I mean, that's a different issue. But it has caused a significant change in how humans play Go. So that basically means it has changed what it means to be human. Yeah, in a very different way than the way you posed the question. Right? So
And for me, I don't know about everyone else, but for me, I love the challenge because I'm always thinking I have this very intelligent machine as a competition, and I'm constantly thinking of how to beat the machine. And of course, the machine is thinking of, I mean, the people who design the machine are
hey,
always
you don't run races, chariot races against a BMW.
yeah,
So there are some things which the machine is going to be doing better than you, right? Physical challenges we have lost, right?
yeah.
Maybe we have to work harder to get a machine to climb a rope, right? But even that is done nowadays, right? So the thing is, yeah, at some point you have to do things just for yourself, right? Not necessarily compete against the machine, right? So the physical battle is lost. They're still fighting the battle.
Yeah. Professor, no conversation with somebody as involved in AI as you are is complete without talking about AGI. Quickly, what are your thoughts about AGI? Is it going to like,
See, I think AGI is a misnomer, right? So there is nothing called general intelligence, right? So you could be great at being a marketeer, but you could suck at chess.
which I do?
So that doesn't mean so AGI. People seem to think that when they talk about AGI, it means is one agent that solves everything, right? So that's not quite the way it is, right? So the target, at least of the technically the target that people shoot for when they talk about AGI, is saying that a machine that can learn to solve problems that it has not been exposed to or not been trained on before, not instances of problems, okay? But problems themselves that they have not been trained on before. Instances of problems is fine, right? So that is what they call as AGI. But even then, right, there are some things that a human would struggle to learn, right? I mean, so I might be good at learning something, but from the life of me, I know I can't learn music, right? So those kinds of challenges are there, right? So in fact, there is nothing out there in nature that really is a general intelligence uh, uh, engine or tool or creature that we can hope to emulate when we are doing these, right? Of course, it's good to have an aspiration to be something better than anything biology has designed, but we are a very long way from achieving anything close to what people mean by AGI. And of course, AGI itself is a bad term, but some people could argue that AI itself is a mistake.
Hmm.
AGI is certainly much more so.
Hmm. I cannot let you go
You can't.
before I ask you this question.
Ouch. Okay, I know what's coming. Yeah.
IIT Bombay CS versus. No, I'm asking you this question because this was the first year that the BTech in AI was available.
Yeah.
And it's clear from the opening and closing ranks that this is one of the most sought after courses. So, what should a student who's crossed JE and got a really good rank really look at?
Let's just step back and tell you about how we put together the BTech in ADAT, right? AI data analytic, right? So there is so much that needs to be taught for you to do AI well, AI properly. right? There's a lot of math background that needs to come in, right? And even from the computing side, I mean, you need to look at data structures in a different way. You need to look at algorithms in a different way and things like that. So we just felt that you cannot take the computer science curricula, right, and then add a few electives or add a few more courses to it and make it into an AI curriculum, right? There will be still some things that you learn without the proper grounding, right? So we kind of designed the whole curriculum from scratch. So this is not a CS plus AI curriculum. This is a purely ground up designed AI curriculum. So there are certain topics in computer science which is like standard in a computer science curriculum which you would not learn in this AI curriculum. That is because you're spending a lot more time on doing AI correctly, right? So if you're going to look at people getting into AI core, hardcore AI jobs in the future, right? Data science and AI jobs in the future, I think the ADA curricula will train you to be better AI scientists and AI engineers than a CS curriculum where you're adding things on top. That is the goal that we have designed, right? And going forward in the future, I'm not going to say that CS guys or, I mean, mechanical engineers or chemical engineers cannot do AI jobs. I mean, obviously, right? I mean, look at the IT company now, right? IT industry is, has a small fraction of it are computer
I mean,
scientists.
look at Arvind. He's electrical engineering.
Close enough. So closer. I mean, you can talk about other people, right? So who are not even computer scientists, or like not even in the circuit branches, right? People from mechanical engineering who are doing great, right? So things like that. Right? So there are a lot of people from a very, very different background who are now at the top in computing and other places. Right? So I think I'm not saying that you cannot move, right? Obviously it's not the saying that if you do CS then you will not be fit for AI jobs, right? I'm saying you'll be able to do the AI jobs better off the bat. So that's basically what we have done with the curriculum. And as the fields are moving, right, you're going to see that you're going to get more and more jobs that require you to be good at AI.
Right.
And right, so then eventually this AI curriculum would be preparing you for that, as opposed to a pure computer science curriculum. Right? I mean, there's always this argument to be made. Okay, if I do electrical engineering, can't I still do computer science jobs? Yes, you can. Like Arvind, you went on to do a PhD in computer science, right? But then maybe if you had done computer science, you are better prepared to. In fact, actually stepping back, if you do a pure computer science curriculum, you're probably not completely equipped to do research in AI because computer science curriculum doesn't teach you the right math. They teach you discrete math and they teach you other things, right? They don't teach you the probability theory, optimization, and other things that you need to do AI better, right? So linear algebra and optimization that you need to do AI better. So, so we teach all of that. We in fact take and if you squint your eye and look at it, we look 20% like an electrical engineering curriculum, and another 30% like a computer science curriculum. So we kind of pulled in all the subjects that you need from different things and created this. And you, of course, you were a CS professor for. I didn't study computer science,
But you were teaching
I know.
in the CS department.
I'm just saying that I'm an example
Oh, right, right.
coming
Yeah.
from outside computer science studios. Yeah. Anyway, go on.
Damn cool.
You're asking a question about me being a CS professor.
No, I was saying that, I mean, it's confusing for parents and students because, on one hand, it's interdisciplinary, it's a little flexible, it's not hardcore. On the other hand, the branch is, as you said earlier, it's a step up. It's like a directional idea. And if you want to go deep into it, you should move straight into it. So they have to sort of figure out whether they want to be 50% committed to CS, 50% committed to AI, or whether they want to commit at all and commit later in life. They have to also balance it with what they like to do in class 12. And in class 12, everybody just likes to fly planes. I mean, think about aerodynamics and rockets.
Really? Okay. My son wanted to do physics. But
Is it?
yeah.
Okay. Interesting. I wanted to build robots.
Yeah.
Because, it's like it's moving and stuff.
Sure. So let me put it this way: it's not like you take an AI curriculum, right? I mean, you do BTech in ADA, you become unemployable for computer companies. Right? So you're doing you're going to do a lot of programming. In fact, you're going to do a lot more heavy duty programming than most branches. And I would actually even go to the extent of saying, including computer science, you're going to do a lot of coding, right? And you're going to do coding using AI as well, right? Which is how the field is itself is evolving, right? So you would be ready for like 80% of computing jobs as well, right? It is not that you do BTech in AI that you are committing to doing only AI and not CS. So at least for the next few years when we IT jobs are still going to be more than the AI jobs, right? But not well, by the time these guys come to placements, right, when they're graduating, right, I think the balance would be more in favor of people needing to know AI as opposed to pure CS. Yeah. But still, I mean, you still be ready to do 80% of the jobs off the bat, right? And of course, most of the companies that come for placements anyway look at other things, not just your subject readiness, right? So they look at how smart you are and other things. So
How good you are at building.
how good you are at building. That is very important for companies when they come. Yeah. In fact, the biggest complaint that many software industry folks have is that the students who graduate from IITs, not just IIT Madras, any IIT, are not good at building large scale software. Mm. That's something we're taking head on and addressing in our curriculum. We have labs that ask you to build large scale systems and also prepare the system for deployment. So that's something that we are certainly pushing for the students to do.
It's very interesting. Thank you so much. We spoke about a lot, and I'm not going to try summarizing because the summary itself will be another 10 minutes. And I've really enjoyed this conversation. I've also had enjoyed the time we've spent together talking to students earlier this year, hopefully next year too. Um, Thank you, Professor.